8.87, we apply our basic sine and cosine to calculate our x and y. This is where it's gonna get weird the first time, and probably every time thereafter. In x and y, this does imply a direction. In the composite, it does not imply a direction. In the composite, what it does instead is it tells us whether we have tension or compression in that member. Don't look at it as directional, look at it as whether there's tension or compression. Thus far, the single mnemonic device that I have ever come up with, ever heard, for remembering whether positive or negative is tension or compression is the fact that positive looks like a plus sign, or is represented by a plus sign rather, that looks like a little T, and tension is spelled with a T.
Yeah.
Literally that's it. I have nothing else for you.
Have you found it valuable just to have them look at structures and say what's being compressed, what's being tense without doing the number?
Nope.
And why would that be?
Far too many of them. Well, for one, when you look at bridges in the web, it's not always clear just off the bat which one's going to be under tension or compression. The cord is always under compression. The stringer is always under tension.
Right.
But other than that, in terms of the web, it's not always easy. Some of the kids will start to pick up on it. Using West Point Bridge Designer, I have found is a great one because they can use because it visually shows the
it shows what's
red.
happening. Yeah.
And so that one you can see. Okay, as the truck goes across, they see it sometimes changing from tension to compression as the applied force moves across. But more, it's usually just from neutral to compression or to tension. But I just haven't had success with that.
Got it.
Yeah. I'm not saying don't do it. I'm just saying that it hasn't, I haven't found it to be a fruitful exercise. But we can think about what's happening here. F sub y, negative 25. This makes a lot of sense. If this joint is pushing upward with 25 newtons of force, then there needs to be something pushing downward with 25 newtons of force. Otherwise, what's going to happen?
It's going to move.
Right.
It's going to accelerate upward. Similarly, this, and this is going to get weird, because this is pushing that way, that means it's pushing that way, which means that in order for this joint to not move, or rather accelerate that way, something needs to be holding it in place. What's the only thing available to hold it in place?
AB.
AB, which means we know that here at AB sub x is going to be positive 14.44. Now, you will get some kids who are going to say, oh, sweet, so we can just put 14.44. No, you get to put this. Sigma x equals ax plus b, ab plus, a sub x plus ab sub x plus ad sub x equals 0. 0 equals da 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 da. ABX, I clicked too many times to get to that. I need to fix the clicks. But anyway, we get to the point where this then eventually shows us, this confirms that AB sub x equals 14.44. That's where we get that piece of information. We don't get that piece of information by just jumping and doing it. We have to take our time. I've been doing these for almost 10 years. I still screw up when I try to take the shortcuts. And I have no problem admitting that to my kids. And there's going to be a joint in just a moment where we're going to see where that really comes up and gets wiggy.
What's that?
Could just yell out Newton's third law, move on, for the
Yeah.
ABFX.
I know. So this technically actually calculated, and I need to fix this. This calculated AB because our 1 is our cosine of 0, so this is actually AB over here. So this is positive 14.44. But then times our cosine of 0 equals our positive 14.44. So they happen to be the same, which is why that gets a little bit weird. But that's, fine. So this becomes our joint table. Everybody get this same set of numbers? Everybody happy with this? Yes? More or less meaning more or less the same numbers, or more or less happy with this? Because that's a key distinction. Okay. So that's all there is about this joint. We then take these numbers and bring them back to our master table. Remember, the only stuff that we're actually going to transport into our master table is this little bit of information right here. Because 14.44 in AB is positive, it's tension. Because AD is negative 28.87, that's compression. This gets important because, and again, we'll talk about this more in various units throughout the year, different materials behave differently under tension or compression. 5 pounds of tension is not the same thing as 5 pounds of compression. Materials behave differently. If you want to prove that to your kids, take a piece of paper. Here's a few pounds.
Yeah, like
Whoops.
that.
I know, right? Here's a few pounds of tension. Here's a few pounds of compression. Tension, compression.
Spaghetti.
Correct, because it's curved. Not curved.
It's folded.
Creased. Take care of space. We'll show you that.
You do that with soda cans, empty soda cans. Blow them, and come together.
Do them both.
It's fun.
I'll just build the AE one, simulation. There are lots of, that's what I was working on. I tend to lose my kids in the computer. That's, and again, that's what I was working on.
Yeah. But we doesn't go hand on. Do you have a 3D printer?
I just not much. I got 2, 3 printers and 3 scanners. I have scanners from the mailbox.
So we're going to do the same thing now, but we need to decide: are we going? Where are we going next? Are we going to joint B? Are we going to joint D? Are we going to joint C? Well, the easy way to look at this, it's a little bit heady to decide which one, but if we visualize them, we're going to see that the logical joint to head to next is going to be joint B. So we're going to head to joint B. And the reason we're heading to joint B is that at joint B, we're coming in with this piece of information. We already know AB, which means that we have one unknown in X. We are given B, which means that we only have one unknown in Y. So we can solve this joint. Meanwhile, if we were to have gone up to joint D, we already know AD, but that leaves us with 2 unknowns in Y. Interestingly, it happens to be the case that it only leaves us with 1 unknown in X, so we actually could solve D as well. But for our purposes, this is going to be better, and it's going to be a better pattern to go with when we're dealing with Warrens with verticals. Warrens with verticals, we're going to want to go in a square wave, but we'll talk about that later. So, Here we set up our joint table. Once again, we've got our joints and our members. We've got B, AB, BC, BD, AB. This is really, really important. Remember. We are taking all of our angle measurements from the positive x-axis relative to the joint. AB is no longer at 0 degrees. It is at 180. That is absolutely critical to what's going to happen in just a moment. That is absolutely critical, or rather what's already happened. That's absolutely critical, because notice that the force in AB is 14.44 pounds of tension, newtons of tension. But relative to joint B, that tension is pulling B to the left. As a result, that is negative 14.44 newtons in X. That tension leads to negative 14.4 newtons in X. That is, we're saying two different things, or rather we're saying the same thing two different ways. That's absolutely critical that they get that. Similarly, this applied force, 50 newtons is 50 newtons is 50 newtons, but it's at 270 degrees. It's pointing downward. So in Y, that's negative 50 newtons. I don't know why I almost said negative 10 newtons. Again, we can go through. B has, because it's at 270 degrees, it's got nothing in X. AB is at 180, so it's got nothing in Y. BC is at 0, so it's got nothing in Y. And BD is at 90, so it has nothing in X. We fill in what we know. The only thing we have available to bring in from the master table are these predominant forces. We take those, we apply them through, sine of 180, sine of 270, sine of 270 and cosine of 180, and we get negative 50 and negative 14.44. Now, you are going to get one or two of your kids who think they're hot shots, and they're going to say, oh, well, clearly this is positive 14.44, and this is positive 50. Yeah, that's going to happen to be the case. That being said, I still want to see it. I want you to prove it, I want you to slow down, and I want you to do it. Because if we get into more complicated trusses, where we have more lines of calculation here, I'm starting you off easy. I'm giving you a break. Don't waste that. So we do our sigma x equals 0 equals AB sub x plus BC sub x. Tra-la-la. We calculate that yes, it is indeed positive 14.44. We put it in the table. We go ahead and we do our sigma y. We do our exact same thing. Happy subs? We then take all of that, we apply it back up into our main table. Once again, we are only bringing up the composite force. 14.44, positive, therefore it's tension. 50, it's positive, therefore it's tension. Cool thing is, we've got one left. Now, you're going to get one or two kids who are going to be like, oh, well, can't we just add this column and shouldn't it equal 0? No. In fact, it is mathematically, I think, impossible for that column to equal 0. There's some Pythagorean stuff going on there, as well as some duplication. It's just not going to equal 0. I've never seen it equal 0. I don't think it can equal 0. So if you get a kid who's like, oh yeah, it's just going to be blah, blah, blah. They're like, yeah, sure, whatever, dude. Got it. Yeah, that'll be fine. Yeah, see what happens. Good luck with your life. Joint table, bring in what you know. Again, the only thing you know is over here in F. So C is at 90, so 25 sine 90 is 25. BC at 180, that's positive 14.44. Again, that's tension, but relative to joint C, that's at 180, that's pulling it. You get the exact same thing that just happened to be. That's the number one problem that I see with other examples of this, or other lessons of this, is they don't stress taking that angle from the positive x-axis. And by screwing that up, man, you wind up in a situation where this is positive. And as a result, you add, and you compound this, and you wind up over here on the left where this tension is like just enormous. And it doesn't equal 0 when you get to the thing, and so you're just wrong. And that's why. And that's the number one reason why. Is that right there. Not taking it off the positive x-axis solves that immediately. Simple change solves it immediately. And then the other thing is when you've got these positive and these angles off the top or off the bottom, forgetting to flip sine and cosine if you're taking them top and bottom. No, that needs to stop. Okay. We will. I'll be honest with this. Thank you for joining us. So we do the same thing here. We've got negative 28.87, and then we take all of that up to the big table in the sky. It happens to be the case with this truss, because it is center-loaded and symmetrical, that the resultant forces are also symmetrical. So if you look at this, I don't know why I say check the sig x and sig y. It's not going to help you at all. So, super fun, happy time. Right? Yeah. That's it. Questions, comments, concerns, fears, regrets at this point? Thank you so much. Feeling good?
Mm-hmm.
I just did a refresher on this for myself.
Yeah, absolutely. Capital C. While we're here, we've got time. Block this out. Take a look at C. Set up a master table for it. Set up a joint table for it.